now I'll share it. Okay. So please write down the new heading: refraction through a glass slab. Let me just decrease the size of this thing. Okay. So guys, suppose I have a glass slab. Okay. And on this glass slab, I'll just introduce a light ray like this. So what will happen to this light ray, guys? What will happen to this light ray? Is this the normal? And tell
Yes,
me,
sir.
if the light is going from air to glass, it is going from a rarer medium to a denser medium. Will it bend towards the normal or away from the normal?
Towards.
Towards the normal. So let's bend the light ray like this, right? And what will happen after this? Again, the light ray now, then it will be going from glass to air again, right? So will it be doing like this? Will it go like this? But always remember, it will go in such a way then that this path, this was the original path, right? Right? This was the original path of the light, and this light ray will be parallel to each other. Let's prove it. Na? Let us say the light ray is incident at an angle of I, and let us say it gets reflected at an angle R. Now can you see over here, guys, if this angle is R, will this angle also be R? Yes or no? And will this angle be E? Let's say emergent angle. So angle E. Is this clear, guys? Till here?
Yes, sir.
Incident. This is the incident ray. This is the refracted ray, and let's say this is the emergent ray, the ray which is emerging out of the glass slab. Now, if I apply Snell's law, let's say apply the Snell's law at surface AB. Can anyone give me, if I apply Snell's law at surface AB, if I say the refractive index of this thing is 1, right? And let's say the refractive index of glass is mu g. So can I write from here 1 into sine of I? I told you, no, we'll do it like this. The product of the refractive index and the sine of the angle of incidence or angle of refraction, whatever, sine of the angle made by the normal, right, is equals to, here it will be mu g multiplied by sine r. Yes, this is our equation number 1. Similarly, if I apply Snell's law at surface CD, if I say this is CD, then can you see again over here, mu g into sine r shall be equals to 1 into sine e, right? So can you see from equation number 1 and equation number 2, the right hand side here and the left hand side here is equal. So hence sine I is equals to sine e, and if sine I equals to sine e, then can I write I is equals to e? So can you see over here, angle of incidence and angle of emergence is basically, angle of incidence and angle of emergence is basically what? Equal.
Equal.
So if the angle of incidence and angle of emergence is equal, then can I say this particular thing? The emergent ray and the incident ray are parallel to each other. Is this clear? Can I say this? Yes or no, people? Angle of incidence and angle of emergence is equal. So can I say this particular thing? The emergent ray and the incident ray are parallel to each other. But can you see this
Yes.
particular thing in the diagrams? The emergent ray is basically a little bit shifted away from the. Can you see this shifted sidewards? This shifted sidewards with a displacement d. Can you see over here the perpendicular distance between the two lines is basically what? D, right? Yes or no? So can I say this
Yes.
particular
Yes,
thing
sir.
that the emergent ray has shifted sidewards by a distance, let's say d. So this distance d has a name. This distance is called as the lateral displacement. Please remember. So here this lateral displacement is basically what? Basically d. And let's try to find out an expression for this, okay? Lateral displacement is d, and let's try to find out an expression for this lateral displacement d. Now tell me this particular thing, guys. If this is the distance d, if I drop a perpendicular from this, wait, what up? If I drop a perpendicular from this to this particular point, will this distance be also d? Let's name the points. This is p, this is q, this is r, and this is s. Can you see two triangles, guys? PQR and PRS. Can you see two triangles? Everyone? I'll try to draw those two triangles again. This is P, Q, S था ना? Triangle PQS या R था? What was it? PQR.
R.
And there will be one more triangle PR, PRS. Yes or no? Can you see two triangles PRS and PQR? This angle at Q is 90 degree, and let's, can you see this angle is R? So can I say this angle is 90 degree and this angle is R? Yes or no? Similarly, this angle was also 90 degree because I dropped the perpendicular, guys. Do you remember? Yes or no? Can anyone tell me what will be this angle? Can you see if this angle is I, this whole angle will also be I. So what will be this angle?
I minus R.
I minus R. So basically I'll draw one more triangle which is having I minus R. So this angle is basically I minus R. Yes or no? Now, can you see there is one thing which is common in both of them? What is that? In triangle PQR and in triangle PRS.
Side PR.
हाँ, जरा मेरे को बताओ. In triangle PQR, can I say this particular thing? PR is equals to PQ divided by cos R. Can I say this? Array, ऐसे. Cos R will be equals to what? Can you see? This will be the base and this will be the hypotenuse, right? Can I say this will be PQ divided by PR? Yes or no? And from here, PR is equals to PQ divided by cos R. Yes or no? Can I say this? Similarly, in triangle PRS, can I say this particular thing? If the, can you see the samne wala side is basically the RS, and that is what we need to find out, right? D. So can you see over here, sine of what is that angle? I minus R. Is it equals to RS divided by the hypotenuse? Will PR be the hypotenuse for this triangle?
Yes, sir.
Yes,
So
sir.
RS divided by PR, and from here can I say RS, which is basically equal to what? D is equals to PR into sine of I minus R. But well, what is PR? PR is basically PQ upon QR. And if I say the thickness of the slab, if I say this thickness, guys, can you see over here the thickness of the slab is T? If the thickness of the slab is T, then PQ and T are equal, right? Yes or no?
Yes, sir.
So will, can I write this particular thing? PR is equals to the thickness into sine of I minus R divided by cos R. Here PQ is equals to T, which is basically the thickness of slab. So can everyone see this particular thing, that this thing is equal to what? This thing is equals to what? T into sine of I minus R divided by cos R. Clear? Please write the derivation. Guys, did you notice this particular thing? Here when I'm writing this particular thing, it is very smooth, right? When I used to write in that exe app, then OneNote used to be like, it used to be like very random. Here I'm finding it very smooth. But anyways, is this clear, guys?
Yes, sir.
So the colors are nice.
The colors are nice. Arey, wo to I did in initially they have given only three colors: black, green, and these four colors they were given. फिर रात में मैंने orange, purple, I try to add more colors in this. Even I need to add one yellow, but I kept yellow as the highlighter. So this is your result. Can everyone see this particular thing? Yellow plus green is equals, yellow plus blue is basically green.
Yes, sir.
See, smart. So this is our result. Any doubt?
No, sir.
After this, let's try to do the approximation for paraxial rays. For paraxial rays, special case. If I have paraxial rays, then can I say this particular thing? This I, R, they will be very small, right? If I and R will be small, then I minus R will also be small, right? So can I say this particular thing? Sine of I minus R will be approximated to I minus R. Yes or no? And cos R will be approximated to R or something
Yes,
else.
sir.
Are 9 cos
1.
1. ठीक है? So D is equals to. Acha, one more thing. Snell's law also I can apply, approximate, right? So Snell's law क्या था? 1 into sine of I is equals to mu into sine of R, right? Yes or no? So can you see over here, if I apply small angles approximation on here, will I be equals to mu into R? Yes or no? Small
Yes,
angle
sir.
approximation. So if I will be equals to mu into R, ये सब कर दूंगा तो D, which was basically T into sine of I minus R divided by cos R, can be written as T, let it be T, sine of I minus R, I'll write it as I minus R, cos of I'll write it as I, 1, sorry. So this will become t into 1 minus r, right? I minus r, right?
Yes, sir.
So after this, can I write r also as I upon mu and take I common? So t into I into 1 minus 1 upon mu g. What just happened? So 1 upon, and that's for the small angle approximation. Clear? Please remember, I should be in radians, right? Guys, this angle I which you are using over here, why is it crashing again and again? ये कल से यही हो रहा है यार, it's crashing. I'll not do any additional options. Okay, done.
Yes, sir.
Okay. Please write the next heading. Lateral displacement due to a composite slab. So basically I need to draw what? The lateral displacement due to a composite slab. What is the composite slab? Suppose I have a composite slab like this, and guys, you can draw it, like with scale pencil, no problem. So guys, can you see over here there is a composite slab AB with thickness T1, this is thickness T2, and this is thickness T3. This has a mu3, this has mu2, and this has mu1, and here let's say it is air. है ना? So tell me how will exactly will the reflection happen? If suppose if a light ray is incidented like this, so it will go like, let's say this, then this, then this, and let's say finally it will come out. Yes or no? And please remember again, initial and final will be the same, right? Yes or no, guys? If you keep on applying Snell's law, so I can write by Snell's law. If I say I'll draw normals at different places. This is one normal. This is another normal. This is another normal. This is another normal. So if I say this angle is I, let's say this is R1, so this will be R1. Let's say this is R2, then this will be R2. If I say this will be R3, then this will be R3. And let's say this angle is E. So again, by Snell's law, I can write this particular thing 1 into sine of I is equals to mu1 into sine of I1. And can you see over here, if I sine of R1, over here if I apply mu1 into sine of R1 is equals to mu2 into sine of R2. So again, I can club this equation. Again, I can club this equation. And finally, it will be 1 into, again, it is in air, no? The sine of E. So can you see again, sine of E is sine of I are equal. So again, these rays will be parallel, right? The original path and this will be parallel. Please use scale pencil. I'm not using any because it takes time for me to draw and all. So again, guys, can you see over here? Always remember a note. If the incident and emergent mediums are same, then light ray then emergent ray and incident ray will be parallel to each other. Okay, emergent ray and this ray will be parallel to each other. Is this clear? And if I say the total displacement is the sideward displacement is d, then how will you do? How will you find out this d, guys? It's easy, na? You will assume. अच्छा इतना लिख लिया guys? Have you written till here? Tell me if you have written from here. Then
Yes.
can you see why, guys? It is still laterally displaced, like it is still laterally displaced by some distance. What will you do? You will assume separate things. For example, suppose this is your first slab of thickness T1 and refractive index mu1. Incident the light ray at the same incident angle, and it will go like this with an angle R1, and then it will come like this, right? So here in this case, individual displacement is, let's say, d1, and d1 I know how to give d1. d1 will be t1 into sine of I minus r1 sine of I minus r1 divided by cos r1, right? Yes or no? Similarly, if I say this is the second slab individually, I'm doing everything individually, right? Of slab T2, mu2, incident it at the same angle. The incident ray at the same angle I, and now it's a medium mu2. Then in the medium mu2, the refractive angle was basically R2. Yes or no? It will go like this, and in this case, whatever is D2, T2 into sine of I minus R2 divided by cos R2, and so on, right? In T3 also you will do this, right? People, इतना समझ में आया? Individually calculate D1, D2 and D3, and the total displacement D will be basically the sum of D1 plus D2 plus so on. What जितने भी slabs हो तो. Is this clear? The thing to note in here is basically this part. Can you see the initial angle of incidence taken is same, right? Hello.
Yes, sir.
This thing is to be noted. The initial angle has to be same. If you want, I can highlight it over here as well. Can you see? This is R1, this is R2, because the slab were different, hence the refractive angles are different. So I guess I made my point clear. Question. Shall we start with the question part? Guys, shall I start with the question part? Snell's law.
So one.
हाँ. एक दो तीन चार पाँच छः. Then I'll teach you today TIR. Today I need to do most of the stuff, right? How much time is left to start with the class?
So can you please scroll down?
So for the slab in between, how can we consider that I will be same? Because
Because tell me this particular thing. When you applied this Snell's law, can you apply this Snell's law between 1 into sin I and first slab separately? Can you apply this Snell's law into 1 into second slab separately? Can you apply this Snell's law into third slab separately, and so on? कर सकते हो ना? Can you do this?
yes,
So
like how Like how can we apply for the second slab?
Can you see this? These are equal, right? This left hand side and this term mu2 into r2. Array, is this equation true?
So
Is
that
this
only I'm
equation?
asking, how is it true? How can we, like, is there a proof for why we can apply it for the slab in between also?
अरे मेरे बच्चे यहाँ पर देखना when we did here कहाँ गया ऊपर और ऊपर. Do you remember these two equations are made separate, but then I later on combined? Can you see on the right hand side I applied on surface AB and then I applied on surface CD, right? So can you see that this term and this term, they are same? That is how we equated both of them, right? Yes or no?
Okay, sir.
So
Yes,
the
sir. Yeah.
same reason I can give it over here as well. Can you see over this surface, if you will apply over this surface between air and mu1 boundary, so this first equation will be there, this with this, right? If you apply it on the second boundary, then can you see this and this will be there? On the third boundary, then this and this will be there. And on the fourth boundary, this and this will be there. So in spite of making many equations, I just wrote everything in one equation. So are
Yes,
you
sir.
getting my
Yeah.
point? So ultimately the left hand side and the right hand side are equal. If this is clear, then this mathematical equation ka form I have written. Can you see over here? I've just written that mathematical form into physical interpretation. Can you make the
Okay.
equation? Make the equation over here. 1 into sin I is equals
Fine.
to mu1 into sin r1.
Yes,
1
sir.
into sin I is equals to mu2 into sin r2. Can you see I made the same equation? So basically for that mathematical equation, I have wrote the physical interpretation separately and applied the formula. So that is why individual I take. Okay, समझ में आया?
Yes.
So calculate individual and then add. Anyways, next question. See there. Suppose there is a cylinder and everyone is able to see a cylinder, right? थोड़ा सा छोटा कर देता हूँ. So everyone is able to see a cylinder, right? Let us say this is the axis of the cylinder. Everyone can see it. This is the axis of the cylinder, right? Now, please see the dimensions. The radius of the cylinder is given to be 3 centimeter and the height of the cylinder is given to be 4 centimeter. Okay. So now there is a small object which is kept over here. Can you see object O, which is kept at the bottom center of the cylinder, right?
Yes.
Now this cylinder is filled completely with water of refractive index 4/3. Now consider the light ray coming from the bottom of this particular thing. One light ray will go straight. One light ray, let me change the color. One light ray will go like this, right? Why the color hasn't changed? Why the color is not changing? Anyways, जाना दो, कोई बात नहीं. So suppose this is one of the incident ray which is coming from the bottom. Suppose one of the incident ray comes like this, and consider light ray from object leaving the beaker through a corner. One more light ray is there, but that light ray is leaving the beaker through the corner. Now tell me this light ray, the second incident ray which I have drawn for this surface. Can you see this surface? This is the medium between air and water, right? Now tell me light is going from denser to rarer. Will it go away from the normal or will it go towards the normal?
Away from all.
So away from the normal, let's say I have drawn it like this. है ना? And if I try to make it over here, can you see this will be the refracted ray, and this will be one more refracted ray, normal one. So the image of the object will be formed over here. Yes, yes or no? So if the ray passing through the corner of the cylinder is used to form an image, this is the question, है ना? Now find the location of image from the bottom of cylinder. This is the question. You understood how the question was cleverly formed? Start solving. Guys, everyone noted down the question? Guys, everybody noted down the question?
Yes, sir.
So guys, suppose if this angle is theta, then will this angle be also theta? If this angle is theta, then will this angle be also theta?
Yes, sir.
If this angle is phi, will this angle be also phi? This is alternate interior angle, corresponding angles, right?
Yes, sir.
The diagram may look a little bit crowded over here, but क्या कर सकता हूँ मैं? Okay, a little less crowd now. So can you solve this question? Can you tell me what is the location? What is the where is the image formed from the bottom of the cylinder? This distance I want, right? So guys, can you see there are two triangles in this question? Everyone can see two triangles over here. Can you see one triangle is like this and another triangle is like this? And if I say P is basically the point at the corner, this point is, let's say, P, this point is, let's say, M. So can you see P, M, I? P, M, O. This angle is theta, this angle is phi, and this is basically where the image is formed. Yes or no? This is where the object is there. And can you see what have you been asked? You have been asked the distance from the distance between object and image, so called, right? Where is the image formed from the bottom of the cylinder? So basically what has been the answer is what? OM minus IM. Yes or no? So let's try to find it out. This distance is 3 centimeter. They have given this distance is 4 centimeter. Yes or no? This distance is 3 centimeter, but I don't know what is MI, but I can find it out. Now, first of all, theta. Theta, guys, can you see over here? Tan theta is equals to 3 by 4. Everyone? If tan theta is equals to
Yes, sir.
3 by 4, then theta will be 37 degree. And do we require tan theta? No, we require what? Sin theta to apply Snell's law. So sin 37 is basically 3 by 5, right? Yes or no? Do you remember triangle 3, 4, 5? Yes.
Yes, sir.
So once we have done with this, then what to do? Sir, still we cannot calculate MI, है ना? IM. So for that, you apply Snell's law. So by Snell's law, Anji, what is the first medium? What is the first medium, guys? Can you see in this particular case? Can you see if I apply this particular on this boundary, this is the angle of incidence. and this is the angle of refraction. So I can relate them with the help of Snell's law, right? So by Snell's law, can I write water ka refractive index multiplied by sine theta should be equals to uh, air ka refractive index multiplied by sine phi? Can I write this? So 4
Yes.
by 3 into 3 by 5 is 1 by sine phi, and cut up it to 4 by 5. So from here, phi's value is 57 degree. Okay, guys, 1 minute. हाँ सर, हाँ हाँ सर बोले, एक मिनट. Hello guys, hello people.
Yes, sir.
Yes, sir. Yes, sir.
एक थोड़ा सा plan change in plan. I got some work at 5:30, so I'll be leaving the class at 5:30. We'll compensate this half an hour extra tomorrow. Is it fine?
Okay, sir.
ठीक है. So, anyways, so five मिल गया. Then what to do? In triangle, this was the triangle. This was P, this was M, this was I, and this angle was phi, and this was found to be 53 degree, right? 37, 53. So 53. So can anyone tell me if this is 3 centimeter tan of 53 degree? What is tan of 53 degree? PM divided by MI. From here, MI will be equals to PM divided by tan 53, and tan 53 is nothing but 4 by 3. PM is 3 centimeter, so 3 by 4 into 3, which is 2.25 centimeter. So this thing is at 2.25 centimeter. The object was at 4 centimeter. So what is the distance between them? 4 minus 2.25, which is basically 1.75 centimeter. Answer. Is this clear? Is this clear, guys?
Yes, sir.
ठीक है. चलो next question. Now suppose there is a sphere, and on this sphere I have introduced a light ray at an angle 60 degree. Okay, this light ray travels like this, hits the other surface where acha guys, can you see over here? This is the center of this thing, and it hits over here, and here it splits into two parts. One ray comes out and another ray reflects back. So can you see ray 2 and ray 1? Ray 1 is basically the emergent ray coming out of the sphere, right? And ray 2 is basically the reflected ray. Now, can you tell me this particular thing? A light ray incident at a point on the surface of a glass sphere of if the refractive index of glass is mu root 3 at an angle of incidence 60 degree, it is reflected and refracted at the farther end of the sphere. Now tell me, find the angle between the reflected ray and the refracted ray. you need to find out what is this angle. Okay, fine. In spite of naming it delta, let's name it as alpha. Find alpha. Everyone understood the question? Then guys, done. What is the answer? Can you see over here, guys? Tell me this particular thing. If a light ray is incident at an angle 60 degree, at what angle will it come out?
60 degrees.
Kyun? Because the incident ray and the emergent ray are in the same medium, right? So I should be equals to E, right?
Yes, sir.
इतना सबको clear है? Now let's try to find out what is this angle. Let's say this angle is R. Okay. So if this angle is R, then can I write by Snell's law? Can anyone apply Snell's law and give me the equation at this surface?
I into 1 into sine 60
Very
is
good.
equal to root 3 sine r.
U into sin r.
Very good. In an easy application, this form of Snell's law is easy to apply, right? ऐसे ही करना, because what will happen, if you will try to write it in terms of mu I by mu r, then automatically someday you will get confused which is medium 1, which is medium 2. Even I get confused in that sometimes, so that's why I avoid that particular formula and I use this format. Easier to remember, easy to apply, है ना? After this root 3 by 2 is equals to root 3 into sine r. Cut. Sine r is equals to 1 by 2, which is r कितना हो जाएगा?
30 degree.
R should be 30 degree. If R is 30 degree, अच्छा, tell me this particular thing. If this is 30 degree, then what should be this?
30.
And since this light ray is getting reflected back, this is the
That
normal,
also
so this should be also 30. So can you see over here, guys? If I try to draw the diagram again on the other surface, this was the surface, and let's say this was the normal. This angle was 60 degree. The angle at which the light ray was reflected back was this is our second ray and this is our first ray, whatever it is. So can you see the angle between them? What will be the angle between them?
90.
And that's our answer. Okay, so this is how you do solve these type of problems and this thing. Any doubt? Any doubt?
No, sir.
Sorry. So with this thing, I'm done with this particular Snell's law, normal application. Let's discuss the next concept, which is basically called as total internal reflection. Now, what is this total internal reflection thingy? Suppose if I have a surface. Huh? And now suppose there is this object is over here. Tell me what will happen. Suppose if this is the light ray. So if light ray is incidented normally, will it go past normally, right? Okay.
Yes, sir.
And let's say this light ray is going from a denser to a rarer medium. So tell me, if I increase the angle of incidence, if suppose this is the angle, then can anyone tell me what will happen to the reflected ray now? If suppose this is the angle of incidence, then the reflected ray will be like this. Yes or no?
Yes, sir.
We know this particular thing that here if I apply this particular thing mu1 mu2, tell me this particular thing, mu1 by mu2 will be a constant thing, right? And since it is going from a denser to a rarer medium, then can you tell me which will be less and which will be more? Can anyone tell me if it is going from a denser medium to a rarer medium, which is denser medium whose refractive index is more or less?
Which is more.
So
More.
the refractive index
More.
of more, this thing is more, right?
Yes,
So
sir.
if I say mu2 by mu1, will it this quantity be greater than 1?
Yeah.
And by Snell's
Yes,
law, we
sir.
know this particular thing, mu1 into sine of I should be equals to mu2 into sine of R, right? So can you see over here sine I by sine R is equals to mu2 by mu1. This thing is greater than 1. So can you see over here I and R will be, if you put it over here, yes or no? Hey, एक second. Huh. So can you see over here this thing is greater than 1, so basically this thing is an increasing function, right? If you keep on increasing I, R will also increase, right?
Yes, sir.
Anna? So if you keep on, we know this particular thing, if I increases, then R will also increase. But R has one limit, right? Yes or no? Does R has a limit?
Yes, sir.
What is that
Yeah.
limit? The maximum, the rest, this angle of refraction, can it be equal what? 90 degree. Yes or no?
Yes, sir.
So basically, suppose if I incident the light ray at a particular angle, which is called as the critical angle, I is equals to theta c. When
Mm.
angle of incidence is equal to the critical angle, the light ray becomes almost, angle of reflection becomes almost
90 degree.
90 degree, right? This angle is basically called as the critical angle. Now, what will happen if I introduce the light ray at an angle greater than the critical angle? The light ray will not be able to reflect back in this medium, but it will reflect back in the same medium. This phenomena is called as what? Guys, this phenomena is called as what? The
Total
total
internal
internal
reflection.
reflection. I'll define it for you. Generally, this definition comes for 2 marks. So write down this thing. Whenever a light ray is incidented in a incident from a denser medium to a rarer medium boundary. So basically, our light ray is going from, guys, please remember, light ray is going from denser to
Error medium.
rarer medium. Important, please remember, TIR happens in this only. When it goes to denser to, tries to go to denser to rarer. So whenever a light ray is incident from a denser medium to a rarer medium boundary, then if the angle of incidence is greater than a certain angle, called as the critical angle. Please write called as the critical angle in bracket. then light ray, instead of getting transmitted or refracted to the rarer medium, reflects back in the same medium. In the same denser. This phenomena is called as total internal reflection. And how do you define the critical angle, guys? Please write this thing, then we'll define the critical angle. It is that angle of incidence for which the angle of refraction becomes 90 degree, right?
90 degree. Yes, sir.
The questions on these are good. So once I'm done with critical angle, I'll do the concept of apparent image, apparent. Guys, I think it will be. Do we have a class on Monday, or do we just have a class tomorrow? Tomorrow I'll be done with refraction as well, right? If I just want to cover up the no, I think I won't be. There is lens which is big. At least we'll be done with covering most of the portions. So, there is prism also, no? Yes or no? So lots of things are there. So
Yes, sir.
at least we'll try our best to cover up whatever is possible. Anyways, TIR clear, guys?
Yes, sir.
Okay. Critical angle, can you define, please? It is that angle of incidence in the denser medium for which the angle of incidence, angle of refraction in the rarer medium becomes 90 degree approx. You can say exact तो कभी नहीं होता. It becomes 90 degree approx. So is this clear, guys? Critical angle. So if this critical angle holds this much important, let's try to calculate this particular thing. So do you remember that when it was incident at the critical angle, the light ray became 90 degree, right? This was our denser medium mu d, and this will be, let's say, our rarer medium mu r. Okay, guys, is the diagram clear to everyone?
Yes, sir.
So can you apply Snell's law? Mu d into sine of theta c should be equals to mu r into sine of 90 degree. And from here, can you see sine theta c is equals to mu r upon mu d? Yes? Yes or no? So from here, can you
Yes.
see over here, theta c is basically sine inverse of. Acha, can I write this thing as 1 upon mu d by mu r? Sir, why are you writing this? Because this is somewhat important. So is this denser with respect to rarer? Can I write it like this? This is your critical angle. Why it is not happening? So this is your final result for. This is your final result for. And please remember, when incidence angle is greater than critical angle, then only it will then only it will. Okay, is this clear, guys? Guys, is this clear? Angle, critical angle. We'll do some questions based on this. First of all, suppose uh, there is a pond. You understand pond, right? And there is a torch or a light, source of light at the bottom. And let's say this source is at a height h. Water has refractive index mu. Here it is air. Okay, guys, here it is air. Now tell me, find the area. Let it be mu only. Find the area of the illuminated surface on water. Sir, what do you mean by this? Suppose you have an instrument which works underwater, right? Now tell me, this instrument will try to send light in every possible direction, right? But there will be certain light rays which will become 90 degree, which will be incident at an angle, critical angle, right? So that angle will be 90 degree, right? Yes or no? Both the sides can all 360 degree complete. So can you see over here, guys? If you incident a light ray at an angle greater than this theta c, what will happen? The light ray will get reflected back. Light ray will get reflected back. So it will never come out, right? So everyone can see. Can you see over here? Okay, there is this light ray, and there is this area on the surface of the water which will be illuminated, right? Yes or no? Guys, you understood the question? Guys, did you understand the question? Okay, there will be this much illuminated area, and remaining part will be dark. Why remaining part will be dark? Because the light ray which will be going like this, it will get reflected back in the same medium, so they will never come out. So the illuminated area will be looking, you will be looking only this region, no, from here. Yes or no? So if you will be looking from here, then you will be only able to see this region as illuminated, because the light rays will be reaching your eye. Here the light rays will not reach your eye because they will go like this. They will get TIR, right? Ayana. So you need to find out what is this illuminated area. For that, now the question becomes very easy. Can you see this angle is theta c? Can you see a triangle over here? This height is h. This is theta c, and can you see this is the radius of that circle?
So for it to be 90 degree, it should be more than critical angle.
Yeah,
Or
when
is
it
it
is
just critical
just
angle?
the critical angle, it should be equal to theta c when it is 90 degree. And for TII to happen, this I should be greater than this angle. Okay. So can you see over here h theta cr? So from here you can say tan theta c will be equals to h upon, r upon h. Yes or no? And from here r is equals to h into tan theta c. After this, what to do? After this, what to do, guys? After this, what to do? The area of the illuminated circle will be pi r square, so pi into h square into tan theta c square, right? And we know this particular thing, sin theta c is basically equals to what? Mu rarer upon mu denser. We have already figured out this thing out, right? Yes or no? And can you see over here, the rarer medium is, let's say, air, the denser medium is, let's say, mu. So can I write this thing as 1 upon mu? Yes or no?
So,
Yes, sir.
If sin theta c is basically this, can you make a triangle like this? Suppose this is theta c. This is the imaginary triangle, right? So this should be 1 and this should be mu. Then only this triangle, according to this triangle, you can make this thing, right? Yes or no? If this will be this, then what will be this? What will be the value of this? Mu square minus 1. Yes or no? By Pythagoras theorem, hypotenuse square minus perpendicular square is basically base and under root taken. right? Is base. So you got the base, and then tan theta c will be equals to how much? Tan theta c will be equal to 1 upon under root of mu square minus 1. So square, and I'll put it over here. It will become, tell me what will it become? Final answer, pi h square into divided by mu square minus 1. Okay, is this question clear, guys?
Yes.
ठीक है. Please write the next heading. Called we'll do some more questions on TIR. ऐसा नहीं अभी खत्म हो गया नहीं. We'll be doing some more questions, है ना? Principle of reversibility and grazing incidence. Now, guys, we know this particular fact that if a light ray goes from a denser to a rarer medium, the light ray, if it is incidented at an angle, critical angle, then the refraction angle will be approximately 90 degree, right? Yes or no? We know this much stuff, right? Yes or no, guys? And we know what is the critical angle. Critical angle is basically sine inverse of 1 upon mu denser rarer. Tensor with respect to mu r upon mu d, or you can write it like this, no problem. Now, what does the principle of reversibility says? It says that the direction, the path of a light ray in reflection or refraction is retraceable if the reflected ray is incident normally. Is incident normally on another mirror, है ना? So suppose, guys, what do they basically mean that, you know, this light ray, can you see this was the incident ray and this was the refracted ray? If suppose if this refracted ray, after traveling certain distance, if I place it, you know, in front of a mirror, so basically, can you see this thing? This refracted ray will be incident ray for this mirror, and it will get reflected back, right? Yes or no? So can you see, when I incident it normally at some place, it will again retrace the whole path. Basically, I can say this particular thing, I can retrace the whole path again, and this is basically called as the principle of reversibility of light. Okay, if in spite of having the angle of incidence 90 degree, angle of refraction 90 degree, if I make this as incident ray which is reflected at the 90 degree, then angle of refraction will become equal to what the angle of incidence was, right? So can you see what I did? I just basically changed the reverse the path of light ray, right? Same medium, everything is same. It is still rarer, it is still denser, but can you see over here, guys? The path has been changed. So this phenomena or this concept is basically called as the principle of reversibility. And when I use the principle of reversibility over here, can you see this case, guys? Can you see the angle of incidence becomes 90 degree? So this thing is this called as grazing incidence. What is this grazing incidence? That the light ray is grazing along the surface and then it gets, you know, refracted from the boundary. Okay. So this phenomena is called as grazing incidence, when the angle of incidence becomes 90 degree and angle of refraction becomes theta c. Is this clear? Is this clear, guys?
Yes.
Yes, sir.
ठीक है. So that's it. Is this clear? Grazing incidence. So if I try to draw two things, grazing incidence from a rarer medium and grazing incidence from a denser medium. So I have already drawn this is the grazing incidence from a rarer medium, right? I'll draw it again. Don't worry. So if I try to draw grazing incidence from rarer to denser medium, right? Can you see the light ray was going from a rarer to a denser medium? So this will happen. But suppose if I have from denser to rarer medium, if I have it from denser to rarer medium, then what will happen? Suppose this is your medium and the light ray is now trying to go into that. So can you see this is your incident ray? The angle of incidence is approximately equal to 90 degrees. So please remember, if angle of incidence is 90 degree, obviously 90 degree will always be greater than 90 degree will always be greater than any type of critical angle, right? So the reflected ray will also be, angle of reflection will also be 90 degrees. So can you see over here, the ray will never be able to go to that medium, right? Yes or no?
Yes, sir.
Yes, sir.
So grazing incidence clear, grazing incidence from rarer medium, grazing incidence from denser to rarer medium is also clear. This is what I'm asking. In the next class, I'll give you some questions which are based on this thing. Then we'll see the concept of apparent object and apparent shift and all. And then we'll leave the questions for J NEET again, 3, 4, 5 pages. And then we'll start with prism. So tomorrow we'll try to do prism as well as the refraction from a single spherical surface. And if single spherical surface is done, then lenses also can be done. So I'll try to finish it off on school level concepts, whatever is possible. Will not try to go into that much detail in JE, or NEET, because only one class is there and a lot of syllabus has to be covered. So anyways, tomorrow some half an hour I'll adjust tomorrow, Will it be fine with everyone?
Sir, tomorrow from what time the class will be?
The class will be from 6 to 8:30. Is it fine? Or shall I keep it a little bit early?
So like 5:30 or something.
Okay. We'll keep it at 5:30 or maybe 5 only. From 5 to 7:30 we'll keep it. 2.5 hours time only. Chalo. ठीक है फिर. Let me just take the attendance who all are present. Who is absent, guys? Satvik not here. Vaidehi not here. Mridul here. Pavitra here. Arya not here. Arya is here. Ishita is here. Dhairya is not here. Shrish is here. Ishita is here. क्या भाई और कौन एब्सेंट है? Able. Who else? Vaishnav is here. Darshana here. Rishma here. Navina is here. Joysha here. Pavitra here. Who else is left? Guru. Okay, guys. You got my attendance. Thank you very much. We'll see you again.
Thank you, sir.
Thank you, sir.
Yeah.
Thank you, sir.
Bye bye.